Okay, so now we're going to learn about multiplying and dividing fractions. So multiplying fractions, they're actually easier than addition and subtraction of fractions. Because when multiplying fractions, you just multiply straight across. Numerator to numerator, denominator to denominator. So in this case, 2/3 times 4/5. You just multiply numerator to numerator, denominator to denominator. 2 times 4, you can just draw an arrow. 2 times 4 is 8. 3 times 5 is 15, and that's it. And so if you reduce, you can reduce, but in this case you don't have to reduce because 8/15 doesn't have a common factor between 8 and 15. So we just leave it. Okay, so again, you just multiply straight across. So another one, 3/4 times 3/7. 3/4 times 3/7, multiply straight across. 3 times 3 is 9. 4 times 7 is 28. If we need to reduce, we reduce, but in this case, we do not have to reduce. One more. Let's see if we can find one where we need to reduce. 1/2 times 4/7. Okay, so 1/2 times 4/7, multiply straight across. 1 times 4 is 4. 2 times 7 is 14. Oh, we have to reduce. Okay, so we have to reduce because 4 and 14 both have a common factor of 2. We can divide them both by 2. 4 divided by 2 is 2. 14 divided by 2 is 7. So we have a fraction of 2/7. You can't forget to reduce, okay? Can't forget to reduce. But I'm going to show you a little trick. It's called reducing within the problem. Okay, reducing within the problem. So if I have 5/7 times 4/15, what I want to do is I want to check to see if diagonals have a common factor. So in this case, I'm checking 5 and 15 and 4 and 7. Well, 5 and 15 do have a common factor of 5. Okay, they have a common factor of 5. So I'm going to divide both of those numbers by 5. 5 divided by 5 is 1. 15 divided by 5 is 3. So now this top number becomes 1, this bottom number becomes 3. 4 and 7 do not have a common factor, so I just leave them alone. Now I can multiply straight across again, but now I'm multiplying 1 times 4, which is 4, and 7 times 3, which is 21. In this case, when I reduce within the problem before I start multiplying, I know I'm going to get an answer that is already reduced. Okay, so 4 over 21, I don't have to reduce it. Otherwise, I would have gotten this big number, 20 over 35, because 5 times 4 is 20, 7 times 5 is 35, and then I would have had to reduce it, dividing both of these by 5. But so if you reduce within the problem, it's actually a little easier. Let's do another one. 5/6 times 3/10. So again, I'm going to check my diagonals. 5 and 10 both have a common factor of 5, so I'm going to divide 5 by 5, which is 1, and 10 divided by 5, which is 2. 3 and 6 both have a common factor of 3. So 6 divided by 3 is 2, and 3 divided by 3 is 1. So now I've changed them all, and I have a simpler problem. 1 times 1 is 1, and 2 times 2 is 4. So in this case, my answer is 1/4, and it's already reduced. Okay, dividing fractions. I'm going to teach you where this dividing fractions came up. You probably have heard your teacher say keep, change, flip. And in this case, this is why it happens. So 3/4 divided by 5/6. I'm going to write it in this form. A fraction is just a division problem, but there's a rule that a fraction can't, in the denominator, you cannot have a fraction for a denominator, okay? So in this case, I need to make this denominator 1. And how I do that is, what I do is I multiply by its reciprocal. Reciprocal just means that I flip the fraction, okay? So I flip the fraction, I'm multiplying it by its reciprocal, but if I multiply something by the denominator to make this fraction still the same fraction, I have to do the same to the top. Okay? 5/6 times 6/5 would give me 30 over 30, which is just 1, right? So I made the bottom number 1 now. And up top, 3 times 6 is 18, and 4 times 5 is 20. So really I have 18 over 20 all over 1 now. But we know that anything over 1 is just itself, so it's just 18 over 20. So this is where dividing fractions come from, because look here at the top. If you notice, I multiplied the fraction by the reciprocal. I kept this fraction and multiplying by its reciprocal. So in dividing fractions, all we do is we multiply by the reciprocal of the second number. And that's where this comes from. That's where the keep, change, flip comes from. Keep the first number, change division to multiplication, and flip the second number, or the second fraction. So now that you know where that comes from, we can just do it, okay? So 3/4 divided by 4/5. We're gonna keep, change, flip. So we keep the first number, we change division to multiplication, because remember we're just gonna multiply by its reciprocal. And we flip the second fraction, which is called the reciprocal, okay? So 3/4 times 5/4, and then we just apply our multiplication. We can check to see if there's reducing within the problem, and there's not. No common factors between 3 and 4 or 5 and 4. So multiply straight across. 3 times 5 is 15. 4 times 4 is 16. And that's how you divide fractions. Let's do one more. 7/8 divided by 2/3. Again, we're going to keep, change, flip it. So 7/8 is kept. Division becomes multiplication. And then we flip the second fraction, 3/2. So then we just do our multiplication. I'm going to see if I can reduce within the problem. 7 and 2, no common factor. 8 and 3, no common factor, so I can't reduce within the problem. So 7 times 3 is 21. 8 times 2 is 16. But here I have a improper fraction. We want to change to a mixed fraction. 16 goes into 21 one time. And then with how many left over, the remainder would have been 5. So that's my numerator. And then my denominator stays the same. So that is how you add and subtract. Actually, not add and subtract. That is how you multiply and divide fractions. Not mixed numbers yet. That's how you multiply and divide fractions.